Today's lesson is on section 4.2, triangle congruence. We learned in section 4.1 that if two triangles are congruent, then their corresponding parts are congruent. Today we are going to talk about the converse of that statement. So if the corresponding parts of two polygons are congruent, then the polygons are congruent. We are going to specifically be discussing triangles in this chapter. And in the case of triangles, enough corresponding parts is 3. We have to prove that 3 parts of one triangle are congruent to 3 parts of another triangle in order to say that the two triangles are congruent. There are 5 postulates and theorems that allow us to say that two triangles are congruent. We are going to learn the first 2 in this section, and we are going to learn the next 2 in the next section, and then later on we will learn the 5th one. The first one we are going to learn is called side, side, side. We abbreviate it SSS. It says when all 3 sides of one triangle are congruent to all 3 sides of another triangle, then the triangles are congruent to each other. I'm going to show this using a proof to show the 3 parts that are congruent. From the picture, the tick marks tell us that we are given certain pieces are congruent. In this picture, we are given that AB is congruent to CD and that BC is congruent to AD. Our reason for those is that they are given to us. The tick marks is what tell us that they are given to us. The key number is 3 parts. They gave us 2, so we have to find the 3rd part that is congruent. One of the things that you look for is something called reflexive sides. We call them reflexive sides because the reflexive property tells us that anything is equal to itself. If 2 triangles are situated so that they share the same side, that would be BD would be in triangle ABD and BD would be in triangle BCD. So BD is in both triangles. Therefore, by saying that BD is equal to itself, that gives us our 3rd piece of congruence. We can add tick marks to that. And our reason would be the reflexive property, since the reflexive property says that anything is equal to itself. Now I've shown that all 3 pairs of sides are congruent to each other, and therefore, because of side, 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 I can say that my triangles are congruent. So I'm going to write my congruent statement that we learned how to do in section 4.1. So I'm going to name my first triangle ABD. And I'm going to name my second triangle with its corresponding parts matching up. A corresponds to C. Since this side is congruent to this side, B in this triangle corresponds to D in this triangle. So B corresponds to D, and then D corresponds to B. So now I've completed my proof. I've been able to show that because all 3 sides of my 2 triangles are congruent to each other, then my triangles are congruent, and my reason would be our first postulate, side, side, side. The second postulate that we are going to learn is called side angle side abbreviated SAS. It says if you can show that two sides of one triangle are equal to two sides of another triangle and their included angle. You have to be careful because it has to be the included angle. Included means that when you put the two sides together, the angle is in between them. That's what makes an included angle. So in this case, our two sides that are congruent are AD and ED. The angle that sits in between them, their included angle, would be this angle right here. That would be their included angle. So if I can show that this included angle is congruent to this included angle, then I can say that my triangles are congruent. Again, the tick marks are givens. So we know, we can write in statement 1 that AD is congruent to CD. It was given to us. That's what the tick marks say. And I can say that ED is congruent to BD. That was also given to us using tick marks. My third piece, in order to use side angle side, my third piece would have to be the included angles. It would have to be angle ADE and angle CDB. So do we have anything that says that this angle would have to be congruent to this angle? Notice the X here. Notice this is an X. We learned in chapter 2 that anytime you have an X, you've created congruent angles. Those congruent angles are called vertical angles. Therefore, because these two angles are vertical angles, we can use the vertical angle theorem to show that those two angles have to be congruent to each other. So my third piece is the included angle between the two sides, and it would be angle ADE is congruent to angle CDB. And my reason would be because of the vertical angle theorem. Since I've accomplished finding two sides and their included angle in one triangle being congruent to two sides and their included angle in the other triangle, I can say that my triangles are congruent, and my reason will be side angle side. So I would say triangle ADE is congruent to, and remember to use corresponding parts. A goes to C, D goes to D, and E goes to B. Looking at this example, my question, can I prove that these two triangles are congruent? My only two options are side, 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 or side angle side. If it doesn't fit into either of those, then I simply have to write that it's not possible to show that those two triangles are congruent. By looking at these two triangles, I'm given one pair of sides, I'm given a second pair of sides, and I'm given a pair of angles. Since I'm not given all three sides, it's not going to be side, side, side. My next option is using an angle between my two sides. As long as the angle is included between my two sides, then it is okay to use side angle side as your reason. Is my angle in the between my two sides? Is it the included angle? The answer to that is no. The included angle would be A and D. So since it's not included, it's not side angle side. Therefore, in this case, I would say it's not possible to show that two triangles are congruent. Second example, again, my options are side, 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 side angle side, or not possible. I'm given two pairs of sides. I'm not given a third piece. So I have to look for something, a pair that is congruent. Okay? Things to look for when you are trying to prove that three congruent parts are there in two triangles: vertical angles, so there's an X, or reflexive sides, meaning the triangles share a side. In this case, I have reflexive sides, so I know that this is my third congruent piece. Therefore, my three pieces are all sides, so the answer would be side, 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 shows that these two triangles are congruent. A couple other examples. This one, again, side, 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 side angle side, or not possible. I'm given one pair of sides, two pair of sides, and the fact that both of these are right angles tells me that those will be congruent as well. So I have two sides, and the angle is included. The angle is in between the two sides. Therefore, this one is side, 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 angle side, excuse me. Last one, side, 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 side angle side, or not possible. Again, I'm given one pair of sides, two pairs of sides, so I have to look for my third piece. It's either going to be vertical angles or reflexive sides. In this case, the two triangles do not share a side, so I know it is not reflexive sides. My only other option is vertical angles. Is there an X? The answer would be yes, that those two angles would have to be congruent to each other because they're vertical. Since my three congruent parts are two sides and an angle, I know it's not side, side, side. The question is it the included angle? Is it the angle that sits in between the two sides? And in fact, it is the included angle. Here's my two sides, and it's the angle that sits directly in between them. Therefore, my answer would be side, angle, side. That concludes our lesson on section 4.2. If you are in regular geometry, your homework is worksheet 4.2, and if you are in CT geometry, your worksheet is also 4.2. Thank you.